Hello, welcome back to Ekascloud AWS Zero to Hero series. In today's demo, we will be discussing about high availability and how to achieve high availability using load balancer, the role of a load balancer, and how to configure load balancer in AWS infrastructure. So for this demo, I have prepared a diagram. Okay. So before moving to the diagram or before configuring the infrastructure, let's talk about what happens if we provision or if we configure an application in a single server. If we configure an application in a single server, there are single point of failure, like if something goes with the server, if memory or the CPU is utilization is high, our request will take time to process, or if there is some issue with the hardware, the application won't be available, or if the availability is on going down, our application will not be available. So end user will be getting service interruption. So in order to prevent this issue, we will be provisioning additional servers in another availability zone, so that if this availability zone going down, the server in the other availability zone will serve the user request. But we have to have a technology called a load balancer, so that what will be the load balancer? Load balancer, using load balancer you can achieve high availability. The application will be available always. So application will be available always means there are chances for issues with the hardware, there are chances for issue with the availability zone, there are chances for issue with the, due to high utilization, the system may goes down. So if such case in such cases, the load balancer can recognize these issues, and it will it can point the connection to the, or it can repoint the connection to the another available server. Okay, this is what the role of a load balancer, and this is how we can achieve the high availability for an application. Okay, so in today's demo, what we will be doing, we will be creating a VPC. The VPC name is custom VPC in North Virginia East 1 region. Okay, the custom VPC, the network address is the 192.168.1.0/24, and in the custom VPC we will create an this is internet gateway IGW. We will attach the internet gateway to the VPC, so that again we will be creating two subnet. There are six availabilities on in one US East 1 region, and hence six subnet. But for our VPC, custom VPC, we will be utilizing only two availabilities on the US East 1A and US East 1B. In 1A, we will be creating a subnet 192.168.1.0/26. That subnet we will be renaming like public one, and another subnet public 2 in 1B availability zone with a network address of 192.168.1.64/26. So after creating the EC2 instance, we will promote these two servers as web servers. Okay, and after verifying the connectivity and the service availability, we'll create load balancer, and using the load balancer DNS name. We won't be using individual server names, so that if you are using the individual server name, if the server is going down, there will not be any repointing. So we have to use the ALB. There will be a DNS name in the ALB after configuration. That name we should use. There are some other configuration as well. You can see there is another logical group in green line. So for to configure this is called as target group. We have to configure this logical group and add the 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 subnets. Basically the availability zone we have to add. ALB will communicate to the target group. This is called target group. I'll show you in the demo. So let's move to the AWS console to build this infrastructure. So the first part is creating a custom VPC. So to create a VPC, since I already added VPC to the favorites, I'm clicking on the favorite menu VPC. Okay, it's taking time. Okay, to create a VPC, clicking on. So let's go to the VPCs. I can click on VPC, create VPC, but I just want to see the current VPCs. So currently I have only one VPC, that is the default VPC. Okay, I'm creating create VPC menu. This time I'm creating only VPC. I'm going to name this VPC as custom VPC as per the diagram. Okay, so custom VPC. Since I'm going to use only the IP version 4 and I'm not going to set up the IPAM, selecting IP version 4. The network range we will be using for this custom VPC is 192.168.1.0, 192.168.1.0/24. Okay, and this section is talking about IPAM or IP version 6, IP version 6 CID. I don't have any plan to implement this IP version 6 or IPAM for IP version 6. So I'm selecting no IP version 6 CID. This should be fine for our demo. Tenancy I'm leaving as default. Okay, using the default tags, just creating the VPC. Now default VPC, sorry, custom VPC is now created. This is the unique VPC ID and the CIDR is showing. Okay, let's go to the VPC console. So custom VPC. Now next step is we have to create an internet gateway and attach to the custom VPC. So to create an internet gateway, on the left pane, click on internet gateways. So this we already have an IGW which is attached to the default VPC. So this is the IGW internet gateway for the default VPC. Default VPC. Okay. So let's create a IGW for the custom VPC. So let's name this as IGW custom VPC. So this is just for identification, leaving the tag as default. Okay, now our custom internet gateway is now created. The state is showing detached. So it's just an now we created an IGW, but we need to attach the IGW to VPC. To attach the VPC, click on the action attach to VPC. Here you select the custom VPC. That's it. Now the VPC, the IGW is attached to the custom VPC. Okay. So the next part is creating subnets. To create subnet, click on the subnets icon in the left pane. So there are 6 subnet, default subnet currently created. These are created by default when we open account in AWS. So to create subnets for the custom VPC, click on the top right corner, create subnet icon, and we are going to create subnet for our custom VPC. So select custom VPC and subnet name, like we are going to use public one as the name, public one, and the availability is on. I'm going to select the 1A availability is on according to diagram. We will be utilizing 1A availability zone, and so this is the VPC address. In this we will be using only 168.1.0/26. So we have taken 2 bits from the host portion. Okay, so for the host we will be getting only 6 bits for the host name, and 2 bits we reserved for the subnet. So in each network you will be getting 64. Okay, so now we name the subnet as public one with an IP address 192.168.1.0/26. Okay, I can also create another subnet in the same window. So I'm going to make it as public 2, and availability zone I'm selecting 1B availability zone, and here I'm going to use 192.168.1.64, okay, slash 26. Let's check the diagram whether it is correct, or yeah, 64. So this is the, and we will be having 64 IPs. 64 IP can be reserved for the host inside this network. So we created two subnet. The first one is public 1, second one is public 2. So this part is completed. Okay, and the next thing is we have to check the route table to see the routes are properly created, added or not. Let's click on the refresh button. You know that when we create a VPC, a default route table will get created. So what is our VPC? So this is a default VPC. The VPC ID is ending with D6. The custom VPC ID is ending with 4B. So 4B, where is that? 4B. So this is the default VPC and this is the custom VPC route table. So the first one is default VPC. So let's do, for better identification, this is a default VPC route table. So route table for the default VPC, okay, and this is the route table for the custom VPC. Custom VPC. Okay. Let's check the routes configured in the custom VPC. We know that this was created by default when we created the route table, when we created the VPC. So currently the address showing is 192.168.1.0/24 and it is showing local. That means this particular route table can route traffic to only to this network. If any request comes asking about other network, it does not know where to forward. So and and also the resources which we are going to configure does not have any internet connectivity as well, this because there are not no routes. So we have to configure a route like any request, any network other than this particular the local network, the route should be uh, forward to internet. This is what the route entry we have to make. So to edit the route, click on edit route, and any request other than local. So any, so we are selecting 0/0.0.0/0. So this represent any network. If request to any network other than the local comes, those requests should be forwarded to the internet gateway. That's the meaning. So we have the IGW created for the custom VPC. Oh, I wrongly selected customer. So let's fix that first. Internet gateway. Let's correct this. Custom VPC. Okay. Route table. Custom VPC. Routes. Edit routes. Add route. Any network. The route should be the right forwarded to the internet gateway. We have the custom VPC. Sorry, custom IGW. Okay. So if any request comes other than the local, it should forward it to the internet gateway. Let us check the subnet association. So both subnet are associated with this route table. So we should be fine. Okay. Now let's go back to the diagram. So we created VPC, we created an internet gateway, we attached, we also updated the routes in the route table. Now we need to create EC2 instances in this uh, in these two availability zone. Okay, you know how to create EC2 instances, right? So let's go back to the EC2 service, and to create instances, click on Instance tab, and in the launch instances, I'm going to select the name as this is, since this is in public one, for better identification, public one, let it as EC2 public one web web server one. That's it. So this is EC2 instance, and this is public one, means this is a subnet, and this is web server, the first web server, just for identification. You can use whatever name you want. And I'm going to select Amazon Linux, and leaving rest of the options are default. T2 micro key pair I'm using. The available key pair with me is, yep, equal key 2. I'm going to place this this particular EC2 instance in custom VPC in public one availability, public one subnet. Okay, selected public one. Auto assign IP I enabled, and I'm going to select a security group. Basically we will be configuring the HTTP, and since this is Amazon Linux, we should have the SSH. Let's create a security group. Since I'm going to open only SSH and RDP, I'm naming the security group as, sorry, not RDP, SSH and HTTP. Is selected SSH and HTTP, just for identification. Okay, and the description also I added the same. So SSH, it will be port 22 from anywhere 00. Let's add the HTTP as well, HTTP, and from anywhere. So these are the two ports I'm going to open in the security group, in this particular security group. And in advanced details, you know that user data, right? So I'm going to actually write some code. So for, I mean, during the instance creations, and when the instance comes up, the server, the couple of services and software will get installed. Basically I want to promote this server as a web server. So using the shebang slash bin bash, this will go to the bash shell, and the DNF for installing, DNF install httpd -y. This will install the httpd service, and systemctl start httpd. After installing, it will start the httpd service. Systemctl enable httpd. This will enable the httpd service. And better identification, echo instance from public one subnet, public one subnet. It's just a message to identify which server it is coming. So this server we have placed in public one subnet, right? So public one, and var www slash html slash index.html. So that's it. So basically this, what this script will do, this script will install Apache HTTPD, and in the default web page it will contain instance from public one subnet. That's it. So let's go back to the configuration which we added. T2 micro key pair VPC we selected custom VPC public one. Okay, so that's about it. Let's launch the instance. Okay, I'm going to open the VPC again. We need to make some changes. One option we have to enable, like Going to the subnet. Okay, let's check the public one. Edit subnet settings. Since this is public, the IP version, public IP version 4 should be enabled. It's a minor change, and the same we need to do for the public 2. You know what this settings does, right? So whenever we provision any EC2 instances, the the EC2 instance will automatically get the public IP version 4. That's it. Okay, let's launch the second EC2 instance in the public 2 availability. I mean 1B availability zone. Okay, let's go to the instances section, and under launch instances, click on launch instance. Okay, so what was the name we added for the first server? I don't remember, but I believe it was EC2 public 2 web server v1 web server v2, whatever it is. Selecting Amazon Linux, and the T2 micro key pair. I'm selecting the kill key 2. Okay, in the network setting, clicking on edit and adding the custom VPC with in the subnet public 2. See, the auto assign public IP is now showing enabled. Since we already created the security group, I'm selecting SSH the one which we created, and going to the advanced details. Okay, adding the user data bin bash. Sorry, bin bash dnf install httpd -y and systemctl start httpd systemctl enable httpd echo instance from public to, just for identification, instance from or hello from in public to. That's it. Anyway, let's write this content to var www html that index.html. This is the default location. Okay, so let's launch the instance. Okay, going back to the instance screen, refreshing.